Okay, yeah, welcome everyone to this week's transaction runtime sync. I'll start by getting an update from everyone. Yeah, Igor, do you have an update for us?
Sure. So I spent most of the week after merging last pair, on fixing some Python and expensive tests that failed due to configuration changes. I think I fixed all the Python tests, but two of expensive Rust tests are still failing. I hope I will be able to fix it soon. Actually,
So why do they fail?
they fail because they still kind of find some configuration in the old format somewhere.
Oh, I see.
And I'm not yet sure where are they able to find that old configuration. But yes, I'm working on it.
Okay.
After that, I plan to introduce a pull request that will finally recalculate account storage. And also I plan to finally study how our Patricia Merkle tree implemented, because I think we need another person who knows that.
Yeah. Yeah, actually, I think Evgeny told me that he already studied it.
Well, I looked into code of a Merkle Patricia tree, so I can help with it if needed.
Yeah, Igor,
I studied some reference implementation before, but I think it wouldn't be that hard to read our particular implementation. I hope, at least.
So our implementation is different from Ethereum, the exact format, but some like overall idea is similar. So if you can read how state is implemented in Ethereum, for example, in yellow paper, if you want. So our implementation has a bit different data structures, but similar overall design.
I actually have read some article on Haber have reference Python implementation. Yeah, but I think it's besides the point, the subject of this meeting anyway. So, okay, if I would have any real troubles, I sure can fire you a question. Thank you.
Yeah. What about the parallel runtime change?
That's like the next thing I want to do after this too, but I'm not sure it would be. I will fit it into this week.
Okay, let's see. Yeah, Alex, what about you?
Okay. During last week, I mostly worked on the PR related to limiting transaction size and made improvements based on review. And so now I'm waiting for a new review iteration. And also, like, I spend only a little time on new task, and currently I'm also waiting for some new task, like a bit similar to like the first one.
Okay.
Also, like, studied Bosch a little, like.
Yeah, actually, Eugene, do you know whether there are some small tasks that would be good for Alex to do?
On near core side, on Bosch side?
Yeah, runtime.
Let's see.
Yeah, I haven't thought too much about
give me like 10 minutes to think about this.
Okay. Yeah, so I did think is it actually last week? Oh, okay. Sorry, the week before that. Okay, so I guess then I didn't. So it looks like the week before I already finished the access key nonce change. So yeah, then I don't think I did anything on transaction runtime last week other than well, I guess maybe I should write this down. So we did some discussion. Promises, well, async execution, as well as storage cost. Yeah, so there is, in case people haven't seen, there is this discussion about that Ilya posted. I'll try to find it here. But anyways, yeah, there is a discussion on the a lot of issues. Well, I guess they are developer experience issues, but the root cause is actually inside our runtime. So we're kind of discussing things like asynchronous execution and also the cost of storage and how we do it today. Yeah, so I think we can talk a bit more about that. Eugene, do you have any updates on the runtime side, or we can just discuss this?
No updates.
Okay. Yeah. Okay, let's talk about. So yeah, there are mainly two issues, right? One is that the way we do storage today is kind of complicated. It's mostly caused by the fact that we do storage staking. And because of this, the user, when they interact with contract, they're not directly paying for storage. And then we basically need to figure out a way to enforce the contract to ask user to pay for storage. Otherwise, user can just spam the contract for storage. And because of this, Eugene and other berry pickers developed a storage management standard. However, there are actually some problems with using that, mainly when there are multiple contracts interacting with each other. You need to figure out how the attached deposit for storage works when you need to refund them. And that actually becomes quite complicated.
That's why we build a standard. So attach and deposit is actually not part of the standard. So you pretty much prepay for all contracts that you want to attach first through a registration. So you basically once register, pre-allocate deposits, and then you call it without deposits. So this is the standard. So if you actually on-demand paying, then it's not part of the standard. It's basically kind of improvement and only works for like, yeah, as you explained, only for the one contract. Actually, my mic is, yeah, but it definitely ideally should be done somehow better, but yeah, there's no direct way of fixing it without affecting cost.
Yeah, so Eugene, do you want to talk about the example we discussed last week when there are like 3 or 4 contracts interact with each other and this becomes a problem?
That's not was part of the storage. It mostly was, the problem is when a transaction, when a receipt fails, so like it panics at some action, we refund the deposit, all attached deposits to the predecessor and all gas to the transaction signer. So when we refund the deposit to the predecessor, we do not notify the predecessor of this action. So you cannot really handle correctly you cannot know if what you called has failed and you got a receipt, or if what you called maybe redirected and failed and you didn't get the refund. So you cannot handle like a chained refunds because we only refund the deposits to the predecessor. So the simple example is A calls B, B calls C. At B, you may want to attach the deposit that was transferred from A. So A attaches 10 near to B, B attaches 10 near to C. Now, if C panics, B may want to refund 10 near back to A, but there is no way to know if you get the refund from C or not, because C may have called D and D failed, and you get the result that the promise has failed, so you don't know if the refund went back to you or not. That's what's the issue.
I see. So basically, it's not directly caused by the store.
No,
Yeah, I think
storage is maybe just partially affected.
Oh, I saw you doing that because you need to attach the deposit for storage, but I guess
I think some implementation wanted this, but that's not the right way.
Okay. Okay. We can maybe talk a bit more about storage first, because I think this is pretty important. And the thing is that with storage, if we want to make a change, it is relatively easy to implement the change. We just need to agree on what to do. With the execution model itself, it is much more difficult if we want to change it. So the storage cost, I think there are some ideas I discussed with Eugene. One idea is that instead of doing the storage staking model, which requires another separate standard for contracts to manage storage, or maybe even two separate standards, the account registration and storage management. If we merge storage cost into gas, then it would be purely paid. It will be purely paid by the caller. So the contract doesn't have to worry about that. The problem is then that the cost of storage rights would be much higher, and we need to figure out like what's a reasonable price there and whether we can afford to do that. Yeah, what do people think about this idea?
Is there any chance that actually, we are requiring people pay for storage, but what if when they kind of freeze at storage, maybe we issue some kind of refund? It would be be almost like it is now, where we just like block some amount from the account, but it would allow us to like to solve the issue that contract itself have to always pay for storage.
So what if we did the following? So you basically implement the storage management standard on a protocol level, kind of. So the first time a user, a predecessor, well, you don't know the predecessor. That's the problem. Like,
what do you mean by
you don't know on which behalf you issue storage?
But what if you just always require the predecessor to do it?
Then you kind of break in the like transfer call API for fungible token. So fungible token is essentially works the following way. You, as a user, Alice, call in fungible token, let's call it DAI, and then die calls the exchange Uniswap. So predecessor for Uniswap gonna be die, but it acts on behalf of the originator, which are Alice. So in theory, you should charge storage for not for DAI, but for Alice on Uniswap. But of course, we cannot verify it. Like, so long as we trust DAI, we can do this. But if you don't trust DAI, then it creates the issue. Maybe if it's kind of like part of the gas.
Well, then yeah, then essentially you're just saying we create a separate thing called storage gas or something like that.
So you do the transaction signer always. So you always account it for transaction signer.
Well, the problem then is like where you still need a way to do the split, right? Because when you, for example, schedule multiple promises, you still need to know how to, like, that's exactly how the gas works today. Like if you introduce a separate thing, you kind of need to need to do that as well, right?
But then you also need to account for the split. So every time you write on behalf of someone,
yeah, that's exactly what I'm saying.
You always say, oh, this is the storage that was added by this user. But then you release the storage of someone else user, you don't get them tokens back. So
yeah.
So this is the issue. Like you can release this gas, or like release the storage of someone else user, and you will get the refund, not that user, because your key is not associated. Like your storage key does not associate with your user ID.
Yeah. What if we just burn that token, right? Like that solves the problem.
Right. So we basically can ignore. Let's say we ignore, or like we act like Ethereum, right? We say you can grow the state by paying gas, but when we release, you don't get refunds back.
Yep. Yeah, and I think proportionally, maybe we can make that price cheaper than what it is today, because today you actually can get it back.
Yeah, but then you are not kind of incentivized to manage storage. To like release storage. So like, because it's gonna be burned, for you, it's more like as a contractor, like you would incentivize to keep the old storage. So if override is cheaper than new write, then you will be incentivized to never release it because the write was already paid. But if override is same price as new write, then yeah, the contract doesn't care in this case pretty much. But
what if we do what the Ethereum does? So Ethereum, like when you release storage, you actually get some gas back into the same call, right?
Yeah, but this is the problem, because let's say you paid for the storage and now I released your storage, so I get paid. That's kind of not desired.
Oh, I see what you mean.
Ethereum solution is not good. There are problems with gas refunds, like existence of gas tokens, for example. It just makes wrong incentives, because the problem is that gas price is variable. So it is possible to spend cheap gas and then get refunded in expensive gas. And fortunately, currently we don't have this problem for storage, because we pay for storage in NEAR rather than gas. And this is pretty good if you look at it. It's like more fair.
But we can just continue to pay for storage in NEAR.
But if you don't, so essentially you're saying we create some separate storage cost, which is separate from gas.
Yes.
We already have this kind of storage cost. It's called the storage staking, or do we want something different?
Yeah, I think the idea is to not do staking anymore and make that part, like enforce that will be paid by the caller. So essentially, when you send a transaction, you attach some like storage cost or whatever that's called.
For this, what we can do, we can introduce a new user state and a contract level. So it's a different type of storage, right? Instead of a global storage, which is paid by the contract, you locally have a storage that is owned by some user, we already have this kind of lookup maps that can be defined who own the storage.
Who own the storage? What does this solve?
This is solve correct attribution of the storage. So you
I
can
see.
attribute the storage, so you can do
I
refunds
see.
for this storage later if you want to.
But
Why can't we do this on SDK level, like define a new collection in SDK which is per user storage, which will in SDK do the accounting? Because I think it's common use case when you store something for users, like token would store balance for users.
Yeah,
so we can have some sort of collection on SDK, which is like lookup map, but where a key must be account ID, and which will automatically do accounting of this each key value paired to that account somehow.
Yeah, it is how it works. It's just the problem is right now the attached near that is attached for storage can be essentially used for just taking it out, and refunds of this doesn't go to the originator, to the signer. So if you issue a transaction that does cross-contract call from A to B to B to C, the attached deposit on C is refunded back to B instead of originator, which is A, like not signer. So you paid for the transitioned near deposit, but it doesn't get back to your account for refund. So this is maybe what we need to address. Then it completely can be solved on a contract level, because we already solved it. We just didn't solve this.
Shouldn't in this case, shouldn't be pass the refund back to A?
Yeah, so this is what not possible to detect because of how our promise results work. So if you can solve this, then like in SDK, we potentially can do refunds properly.
If B calls C and schedules a call back to B, like wouldn't it detect this? Wouldn't this callback see that the call to C failed, so it knows that if it failed, that it has to refund?
It doesn't, because if C returns a promise to D, then B will get a failure from D potentially, but C keeps the attached deposit. So we need to detect whether somehow detect, maybe have a promise ID, unique promise ID when you schedule it or something like this. And then you can basically match this unique promise ID when you get a refund or result back.
I think when you get a callback, maybe this callback should get attached tokens if the original call fails. So this refunded token should be attached to the callback. So the callback can see that there are tokens attached or not.
So this is the issue, because you can have multiple callbacks on one promise, and then it's unclear which one gets the refund and like getting notified about
and
the
I think
refund.
that this feature is not really needed. You don't really. So, do you ever need to have multiple callbacks on a single promise because they complicate things?
Well, you don't always have to schedule a callback on yourself. So you can have basically you can return a promise and then have a callback on this promise. And also you can do, and someone else may already had a callback on this promise. So the promise will have 2 callbacks now. Plus there's like a joint callbacks, which is like you get the result of 3 promises, for example, but then you can query for each what was the refund on this.
So wait, why would you ever have one promise with 2 callbacks? What
So
does
you
that
can
look?
call, basically you can return any promise ID from the execution. And then one of the promise IDs can be either a callback, which is your callback, or you can return a promise ID. And this is something that you scheduled. So let's say B calls C and attaches a callback on this. And then C calls D, but then instead of attaches a callback, but instead of returning the callback, it returns D promise. So it's like maybe just a login callback. So it just want to say, oh, did it succeeded or not? But I don't care about the result. So I want to just like log it or something like this.
Okay.
Then this D call will have a callback to A or to B, and as well as callback to D or to C, sorry. So basically callbacks are flexible. It just
Oh, you're saying, okay, I see what you mean. Okay, that's not okay. I think we're inflate what callback means. So you're saying D basically was sent to data receipt or something like this.
Yeah. It has 2 outgoing dependencies.
Yeah.
Not dependencies, but outgoing receipts.
Right. Okay, I think we're out of time.
Yeah, basically let's not design a new storage, but instead let's try to solve the refund problem. If we can solve the correct refunds for storage, then we can design contracts to do refunds correctly. Maybe as part of attached deposit, we can specify who attached the deposit, but that's a little weird. It requires you to change the mechanics how the attached deposit works, but I don't know. Okay. Anyway, we're out of time.
Okay. Yeah. Thanks, everyone.